for the introduction, and well, thanks for coming. Quite disciplined of you. I know that Saturday morning at 9:30. So.
Microphone?
Oh, sorry, yeah. I just want to talk about a couple of things. I mean, the idea of prototyping for us, I guess, has been quite important for the last, years, particularly as a way of thinking about representation in a different way. So we're working at one-to-one whenever we can. Prototyping in a way has a lot to do with sort of experimental work we're doing in the office, but as a way of setting up a project. I think at the end of the day, we're building architects. We have a building practice, and so in that way, the prototyping is really in support of that. The other aspect, this idea of bricolage, and this has to do with the next book we're doing for the AA on fabrication, is this idea of working as craftsmen, the idea of using sort of odds and ends as we find it, as found, how we can use it. Means also it's a very inclusive practice. We work both digitally as well as analog. So this idea of sort of an experimental field, bricolage, and the idea of prototyping as, in a way, a new idea of representation that somehow closes this gap between an idea and how we actually build. Another thing that we're doing is this idea of the relationship between academic teaching at the AA, recently at Harvard with BMW, research component, which sort of jumps back and forth between the academic work and the practice itself. And as said, the practice where we're dedicated to the European competition system. We're building in Germany and Switzerland, the U.S. and Korea. And how all these areas support each other. The soundbite here is really about to say that it's a material practice, in a way how we use materials, how we can think about them, and the tools that shape those materials. This sort of backing up the practice. Instead of starting with form, we typically start with processes that then lead to form and programming. To begin with, about 10, 15 years ago, as we were working in this sort of high-tech German environment, we began to learn more and more about the tools that were being produced in the factories we were building. This is an example of Trumpf as a machine tool company in Stuttgart that we were building for the last 10, 15 years. Their great invention was laser cutting of sheet metal, but also digital bending and punching, and we began to think about how we could use these kind of tools for producing architecture. So in a way, as I was sort of hinting at, there's this reversal of the process where when we were students at the GSD at Harvard back in the late 80s, when software was emerging, the sort of process was working this way. You'd start with a form that software would, Form Z and some of these things you remember, and think about how a form could be materialized in tooling. So the way we work now is really a reversal about this, where we'll again start with the material, begin to look at tools, and many of these tools are sort of driven by software that would lead to types of form. So the idea was this, in this kind of diagram here, looking at different tools, beginning to anticipate how they can, in a sense, transform or manipulate materials and where that might lead us to. At the same time, we keep adding fabrication partners. We started with Trumpf. In the meantime, and in relationship to particular materials, we keep gathering different sort of fabrication partners that help us understand what their processes do and how we might, in a sense, exploit these or begin to use these for architecture. At the same time, some London-based, German-based engineering partners, we began to work with them very closely. And particularly up front in the design process, where we're working with these guys very much at the beginning of the process. In order to do some of the more experimental work, we've also acquired a number of different institutional partners who have helped in terms of, say, collections or even the exhibition that we have here, installations, gallery expositions in order to test different sorts of ideas. As indicated, this idea of the Atlas of Fabrication, which we did, I think this was about 3 years ago, we began to formalize a lot of these techniques into a kind of catalog. It's a catalog that we continue to add to. We're doing the second edition of this in a few months with the AA. But the idea not to show buildings per se that we've done, but to focus more on different process techniques and how these might become an archive. So this was work that we did with students. We would send students off to different companies. They would look at different material processes, in a sense beginning to archive this work, or to become our own sort of experts in terms of producing building catalogs that we could use or not use depending on the projects they can contribute to. So yeah, as an American architect, this was very different than the way that we were trained, where we were using building catalogs basically to add to some of the to the buildings, to use for the buildings that we were making. So to give you an example of one of these processes, revolving laser cutting is something that Trump developed about 6 or 7 years ago. These are pieces that are upstairs in a way. These are, again, students coming down and really just experimenting with these machines to understand the capacity of these machines, how fast they can cut, how much detail we could acquire, to begin to understand the economics of some of these cutting, and then to slowly begin to think of applications for this. So in this case, we constructed an array of this cut tubes for an exhibition in Basel, in Switzerland. The next step being a direct application in a building process. In this case, these cut tubes rotating both as a kind of sun control system for a showroom in Sweden, at the same time having a formal performance aspect, but also as a way of showing the machines that would be displayed in this showroom. So this would be kind of a fairly compact process of how that might work. Other examples, space frames. As I said, we're doing competitions in Europe, and one of the ideas is through a competition process to really embed some kind of a research project in each competition. So in this case, we went back to the 60s and 70s. We looked at how space frames were produced. Now these can be done parametrically. They can be done through laser cutting to produce, in this case, a study for a space frame facade for the Kunsthaus Museum competition in Zurich. But again, as a way of having that as a kind of project within the larger project of the competition. Other examples, sometimes shifting from one material to another. This is a prototype for a chandelier, a kind of installation we did initially at this gallery in Berlin. This was then perfected. Again, this idea of prototyping, I think, is also one of failure, correction, back and forth. This ultimately became a kind of lighting fixture for the Deutsche Bank. But through our discoveries of material cutting, in this case perspex, colored perspex with laser cutting, and using scripting software to produce a whole array of tangent topographical cuts that made this array. This was a similar thing that we did for the Venice Biennale, where we used stainless steel that was also cut in a kind of array that could be moved in almost a pegboard type of structure that produced this type of landscape of differentiated elements, but checking them and then sort of installing them in a quasi architectural application, again thinking about that further down the line. Another thing about this time that we discovered with the laser cutting was that they could laser cut in a kind of spiraling cut that would lock these tubes together at the same time, could produce a radial system that we could adjust. So knowing that, we began designing different forms for the German Architecture Museum, for a pavilion for them in their garden, knowing that we could, in the end, used digital bending to produce a whole array of tubes at different radiuses that can contribute to these forms. We ended up working with Werner Sobeck, making the forms, looking at different versions of those, and then thinking about how we could clad this system. In the end, Werner developed a system, a kind of polycarbonate shingle that were attached to these sort of standoffs here that were then simply and very quickly attached with Velcro connectors very quickly for a pavilion that we could build in the garden. This is being the museum at the German Architecture Museum by Ungers, and this showing this sort of shingle overlap, which were then later embedded with photovoltaic cells for the piece. Another test about this time was with wood construction for a pavilion in Norway, using the Norwegian wood industry to produce CNC cut ribs that could produce a series of cells for a Norwegian artist, which he could use and add to over time. The idea, and with this system working with Holzbau Almen and the Black Forest, was a series of cells that could be clad with different ideas for membranes, either PFE or fabric cells of a system that we could add to and change relatively quickly for this exhibition. So in this way, it was a very simple rib system with cross basing through this, but with the idea of the cells being overlapping conditions. The pieces themselves, she could use these spaces for different kinds of installation having to do with the senses. The idea that this system, that every year there could be another cell added to the project, so that within 5 or 6 years she would have an entire array of these pieces that would be interconnected to each other spatially. So the idea of the cell in a way as a kind of one-off, but one that could overlap and be connected to a much more integrated and, in a sense, integral system. At the same time, and this was a discussion we had in St. Louis, I guess, in the spring, was the idea of patents, where we actually end up inventing components for certain projects that have to do with our prototyping. This, in this case, was supporting our friend Tacita Dean, who did the project film for the last Tate installation for the Unilever series. In this case, Tacita has a commitment to analog film. At the same time, she was interested in the idea of using masks in an analog camera to produce certain effects with this project film in terms of overlapping of images. As you see indicated here, even in a way sort of rhetorically showing the sprockets on the side, would talk about this kind of history of analog film. In our case, to support her, we developed a series of 3D printed film masks that would slot perfectly into the camera, that would allow her different techniques for masking or revealing different kinds of images. So this is the piece, which is a kind of plastic 3D printing, which you'll be familiar with, which were then painted matte black and then could fit, sort of slot into the existing camera frames in order to produce these effects. The next part of the presentation, I think we're kind of okay for time, probably.
Fine.
Brilliant.
Fine.
Okay. Was the idea, as I said earlier, that we're a building practice. So this soundbite from Icon magazine a few years ago was this idea of everyday buildings. We're building office buildings, factories, to use the kind of research component of the practice and see how that could begin to affect the kinds of buildings we were producing. For example, this was about, I think, 2007 we finished this project in Korea. We'd never built in Asia before. It was completely foreign building culture to us. This incredibly interesting, very heterogeneous city and how we might work there. Because we were building in a new master plan that was literally being built before our eyes, we became interested in how in a kind of core and shell building, an office building, We looked at examples. This is from our graduate school days, the Hancock Building in Boston. We were very curious about how we could sort of revisit this, the curtain wall project. And this project from Pei and Harry Cobb was one of the first buildings in the 70s that had this very sort of audacious, reflective, mirrored facade. At the same time, there were always, and the facade at the time was this idea of mediating between the historical city, this is Richardson's Trinity Church here, and the city beyond. But what fascinates us about this facade was this sort of imperfections in a facade that was trying to be perfectly flat, and the slight nuances of a reflected surface in that situation. So in this case, prototyping, we started building 1 to 3 mock-ups in our courtyard. So this is sort of pixeled, almost like a kaleidoscope, our office spaces, our lofts in the background. And we found with relatively small sort of geometric folds in that facade, you could get an amazing amount of visual effect. The building itself that we were going to marry this facade to is a core and shell building with an offset core here in the corner, underground parking here, and then a facade on a steel building that we could simply wrap around it with showrooms on the lower levels and then offices above, and then continuing the facade above to produce a kind of a roof garden. So here's the building here. Here's this master plan that's literally being built sort of from left to right, one lot at a time. And then this is the context, which we had very little idea what it was going to be, but with the idea that the building would react to these new buildings around it, whatever sort of came up, as well as traffic, people moving around, the weather, whatever. So the building here being located here again in this fairly sort of mashup of a master plan in northern Seoul, and then begin to look at ways of using limits of glass. The glass is from Viacon, from Minnesota, from the US. We knew that we had a limit of the format, so we began with a grid, began introducing diagonals. Then the next move in this system was combining, and this also had to do with the economics of the project, but combining three-dimensional elements with two-dimensional elements that allowed us a huge amount of variation in the facade, with at the same time using really only 2 types. One like this, a three-dimensional type, which we could then flip upside down, and then combining that with a two-dimensional element to create a highly textured facade that works very, sort of optically very dynamically, but within a depth of only about 20-25 centimeters in the whole piece. Despite all the digital sort of working of this blah blah blah, we ended up going back to the shop and just producing wood models by hand, simply to understand the geometry and how these pieces could intersect, and how we could build them again relatively simply, and then combine them with glass elements that would fit in here. So this is again the kind of section depth that we were working with. Again, we were very interested in the history of curtain walls, how we could produce that for a low E reflective glass, and then how we could control the geometry. We ended up working with Arups Hong Kong, who in a sense did workshops with the local fabricators. Jerry from Arups doing workshops in terms of controlling quality, tolerances, and then bringing the US glass and then bringing them onto these frames. So very high-tech CNC cutting versus very simple sort of kitting of those joints for silicone. A combination of, again, what was sort of at hand, what made sense in terms of producing this being one of the more complex corner units that we produced. But I mean, I think there's both the ambition and the kind of will from these fabricators there to do something like this, in the sense that there was no precedent for this project. The client asked us to test it, which we did, in terms of wind and thermal insulation, waterproofness. The first prototype passed, so we were given approval, and then could go into production in terms of putting these things, prefabricating these things off-site, and then bringing them on site so that they could be lifted in place even though some of them are quite huge, but we could lift them in place very quickly. So again, a Korean construction site where being on time, on budget was extremely important, like everywhere else, but that they were able to do this in a very expedient manner, again, to produce something for us which was quite extraordinary, and both in its appearance and even in the precision of how it could produce. Again, a kind of technical solution at the same time. We were very much aware of the effects this facade would produce, how it would react to traffic, to movement, to changes in light and weather, or even the insane window washers, which sort of drop off this thing. As well as different projects. I think another idea was working at different scales within the project. So we were working on wood cladding systems on the interior, a suspended steel stair that we engineered with Schleich-Bergemann in Stuttgart, but different sort of emphasis within the overall project. Having done that, we went back to Stuttgart to do a couple projects for Trump. Again, this is this digital fabricator, the machine tool company that we started with, where we did a gatehouse for them, where was our first chance really to do a building that would, in a sense, embody all of their technology. We went back to Werner Sovek's office, and Werner had been dying to do a building with an insane cantilever. We had columns over here, which he just knocked out literally of the model and said, we're going to do it like this. So our first column grid is back here. The other one's here. There's a gigantic chunk of concrete in the ground to keep the whole thing from tipping over. And then produce this 60 centimeter depth steel roof truss. To begin thinking about that, we knew that Trump were producing these things for ship decks and tables. This is laser cut and laser welded. It's extremely stiff, extremely strong building component. So our idea was, well, maybe we could take this technology and scale it up to the size of a cantilevering roof, which was a lot easier said than done. We inherited these sort of diagrams from Werner's office that showed the loading. We wanted to make that both a structural idea, but one that was also legible. You could read that through the construction. So at the end of the cantilever, you have a very light structural grid triangulation, and then much more compact at the compression, tension back here. And then again did a mock-up of that system. So the bottom plate is varying, as well as the sort of webbing here. These are also changing in dimension, integrating things like the gutter system, but then combining different sort of trades in terms of laser cutting at the same time, good old hand welding at the expansion joints here, mechanical fabrications, and then ended up pre-fabricating the strips off-site, brought them to the site at 3 o'clock in the morning with these gigantic lorries, had the columns already set up, and then very quickly sort of bolted these pieces together, put these gurneys around them, and then lifted them into place over a very short period of time. I think we did this all in about half day. This was sort of the moment of truth. Dropped the thing. The roof bounced a couple meters up and down, and then slowly settled into place. All 2,000 workers are out watching this happen. So we felt like me and Sandro smoking a cigar while the National Museum was lifted into place. So in a sense, that was very much the experimental case with the building. I mean, something like this you can calculate it, but it's extremely dynamic. We had a camber going this way, a camber going the other way, and then in the end put sandbags on the roof to drop it into place, and then use the entire roof as a kind of indirect lighting scheme. In a sense that this really is the gateway, this threshold to this sort of factory campus. But again, like this other project, developed secondary systems in it. This is a traditional way of making, it doesn't look very fast, but it's a traditional way of making garden walls in Germany. We interpret that as a glass double curtain wall. with a kind of decorative perspex tube infill, which also works as sun control. This was done in, as I said, a facade system that's entirely glass. It's either acrylic or float glass, this being also acrylic, so that the entire facade is either transparent or translucent, depending at which angle you look at it. And in order to do that, to solve these kind of technical problems, Werner's guys developed this gasket detail so that when the roof is loaded with, say, a meter of snow, it'll be able to move without crushing the facade system. Other systems like underground sun protection can be brought up additionally to bring additional sun control for such a system. But again, no precedent for this. This was something we could simply sit down with the engineers, think about, invent, and then produce through a series of tests to make that. At the same time, we did this project for Trump, the cantina. This is right down the road from the gatehouse. In a sense, this is the social center for the campus. This is where the workers, white collar, blue collar, everybody comes here for lunch, but also for lectures, for musical events. And to think about, I guess in the German sense, the roof as a kind of fifth facade that we can articulate. This is the structure of it. At the same time, it's a filter for natural daylight, for artificial light, as a kind of, almost a kind of leaf-like structure that encloses the spaces. One of the things we did, which kind of goes back to some of our earlier projects, which we're interested in landscape, was to excavate the site here to the level of the tunnel levels, which tunnels connect the entire campus, and produced a kind of amphitheater space under this large structure. So you have the kind of Autobahn over here, the factory here, the ground kind of slipping underneath and up around this piece. The roof itself is deep. It's between 1 meter, 52 meters. Worked with Holzbau Amann again in the Black Forest. We drew it. They redrew the entire roof, every connection, every bolt, every screw in their software, and then went into production. So this is Gunther over here redrawing all of our drawings on their hardware and then going into production. So this is a production run for us over here. On the other side, they're running Sugar Aubin's Pompidou project. Had built a prototype of that system to show the connections, to show the finishes, to show the economics of this. We kept dumbing it down, making it simpler to the fact where the prototype itself was integrated into the building itself. So here's the fabrication happening with the CNC technology. There's very, very little redundancy in the geometry, unique conditions. The depths relate to the structural loading. Used a steel sort of mainframe for this to get the spans that we wanted to get. Brought these all pre-cut and then were staged. These are sort of little helper columns here. We're able to put this up also extremely rapidly. So this is, you know, every 3 or 4 days we could add another section into this kind of polygon-shaped roof to finish it very quickly. So this could go into operation also quickly. As with the other project, we ended up designing a curtain wall system for this one also, but a fairly simple plan with these series of column clusters, which are triangulated to stabilize the lateral forces here. By going underground, we generated a mezzanine here, which went into use right away. A very small core here, which also stabilizes the building, and then precast stairs, which complete the kind of main structure. As said, there was these cells could be programmed. We could target each one as we needed. The darker ones are being skylights. The lighter colored ones are artificial lighting, and the rest then designated for acoustical surface, so that each cell had a kind of role to play in the overall structure of the building. So this is the effect of the roof in terms of the lighting, a very flexible space, the mezzanine with precast concrete stairs to the top, and then the facade system that we developed up over here. So it was an interesting building for us. It was also for us very experimental. also working with Matthias Schuler from Transsolar. Ideas about sustainability as timber as a sustainable material, but also in terms of the heating and cooling of the building, as well as 90% of the time being able to use natural daylighting for the spaces inside. As said, and I guess this idea of a kind of complete fabrication project, we could control other details in the building, such as the ceramic tiles, working with NBK. They were happy to make a custom tile for us out of terracotta and glazing that so that, in a sense, for one building, we could design and produce the entire building systems for this. I think the only things that were off the shelf were the door handles on the 3 or 4 doors in this building. But the idea of being able to relatively easily control all of the building systems within this, the architectural ones, of course, the mechanical systems are independent of that, but we were able to do that, which in our experience of building in other places like America, were almost impossible to have that amount of control. I just had a couple other projects I want to show at the end. One of the things we're shifting to now is concrete. We're looking at concrete. This is, and also with digital formwork. I think this is like a whole new frontier for us. This is a building we just completed a few weeks ago in Berlin near the main train station. It's the first, I guess, building block in this master plan here. This is one of the last really large patches of ground left open in Berlin that hasn't been developed. This is the government center back over here. So in a way, the building is extremely visible in the city. It was a kind of political football. There was a lot of intention on it. There was a lot of sort of dodgy, hotels that had been built around the train station. So there was a lot of pressure on this building. It's a developer building for offices for Total, the French petroleum giant. In this part of the town, I mean, Berlin is flat. It's 22 meters usually. So in this case, this will be one of 3 towers at this site. But we wanted to look at the geometry. We were able to free this building as a tower from the 22-meter base that was indicated in the master plan as a freestanding tower. The idea, the investigation here was not to do a curtain wall, but really to look at a load-bearing facade of precast concrete. This is the building next door that we're working on now as a curtain wall that will produce this kind of pedestrian passage. This is the main entrance to the building. But to produce essentially a column-free interior, the core is offset here to the west, and then a precast concrete, like a 135 grid that goes around the building to enclose it, to have well-lit, relatively shallow office spaces that would then produce this kind of visual effect with the facade. So these are these precast pieces which are attached back to the floor plates that has a kind of geometry, which I'll show you in a minute, that produce these kinds of diagonals that wrap around the building, which gives it a kind of scalelessness. This is a precast element that's made in Stockstadt. These are the same guys that did the new museum for Chipperfield. So we knew they could produce something with an enormous amount of precision, with an enormous amount of sort of color consistency, and produce them actually quite economically. This ended up being an 800 euro a square meter facade, but also to use this depth, which is sort of a traditional way in Berlin of producing facades, particularly in industry where you have a deep facade which, when seen oblique, is closed, frontally transparent. For a silver DGBNN sustainability, that means that we have exterior sunscreens integrated into this, triple glazing, and then a mechanical level at the top. In order to do that, and also with the city, we did workshops for the city. We produced a mock-up of this facade. The city could see the precision of it, optically how it was good, and we could go ahead with this. So in this case, we're now using digital technologies to produce the formwork. Although there's a lot of redundancy in this system, we still ended up having, I think, about 160 unique pieces within this whole puzzle of putting these things together. But they're extremely precise to a couple of millimeters. We could also get a very beautiful matte finish that they did with a kind of acid wash on these components, and then put them together. The system works as a kind of sandwich. We have precast on the interior, precast these ornamental pieces on the exterior, and then a kind of thermal glazing component in the middle. In the future, and working with Zipline, we'll try to eliminate this layer, and we'll take this one as a kind of exoskeleton and connect that back to the floor slabs with an isocorp connection. So that's sort of on the table for the next move with this. We had too much movement, 70 meters high, quite a lot of movement thermally, but that would be the next sort of process in this kind of development. Formally, the T's offset with each other. They sort of stagger to produce this kind of effect. There's a so-called K-shaped, almost like an origami fold that works over 4 stories. These pieces are ornamental, but they also provide the lateral support for wind load. They stiffen the frames behind, so they did have a kind of component. In either artificial light or oblique light, you get probably the strongest effect in terms of the geometry of the facade as a kind of wrapping quilted surface, but in a way, compared to say Korea, a much more physical, much more material, less optical kind of surface that for us was an interesting way of looking at this raster facade or this gridded facade, which is a kind of Berlin typology, and how we could take that typology in a way evolve it through new technologies, new ways of casting, and new ways of kind of repetition. So this has been an exciting project for us. Like the others, I think also looking at custom tiles for the lobby, millwork and steel work that complements some of the systems to the exterior, but again be able to control this with local ceramic workers. I think we're sort of gearing up for doing a ceramic facade on the next project, so this is something we're quite interested also. At the same time, we won a Wholesome Prize for the Smart Materials House. This is a concrete project also in Hamburg for the IBA for low-income housing. We could build this 4 levels of flats for 1.4 million euros. We work with Schleich, and on this project also with Matthias Schuler. Schleich's great interest is infralight concrete. This is a self-insulated concrete that can use either recycled glass or clay as a kind of insulating aggregate. It's a third the weight of regular concrete. We're using it like 60, 70 centimeters, so this idea of thickness or poché was an interesting one. And then using the decking, the sort of tension pieces in timber and glue laminated pieces. So this combination, again, like the diagram in the beginning, this idea of beginning with a particular material and seeing how we could use it. We knew, and of course we're fascinated, this is a project we did at the AA years ago, but the Eastern European Plattenbau, prefabricated concrete elements, this is Khrushchev, seeing how these things, which are, as you know, all over Eastern Europe, were economical housing out of precast concrete that produce, a kind of interesting amount of variation within those kinds of types. So this was a kind of historical footnote for us how to work, but with the ambition of really producing a building component that could kind of multitask. They had a kind of formal language about them. There's serpentine, which also makes them self-supporting. We didn't need scaffolding. We could also integrate the heating and cooling in these elements. It's sort of one-stop shopping. The finishes on the outside, the inside, you don't need any finishes. You don't need any additional materials on it. It's done once it's cast. We could combine these in a much freer floor plan. We didn't have the notorious sort of German cold bridge problem. So these wall pieces can stack over each other almost like a house of cards. As long as they have bearing along that lane. Very simple core out of concrete or wood works also. So you can have a very, in this kind of 9 square, an open plan as a loft, or It can be cellular and broken up as a kind of work-live space for this International Building Exhibition, so that the perimeter of the building through these 6 things articulate the space, but also how the light comes into the space. So this is a configuration where it's very open. We combined that with wood and triple glazed glazing units. This is the sort of interior effect that we anticipate with the system, this being the timber floor decks, ceilings, and the pieces themselves. Like the Korea project, we can take 1 or 2 different types. You can flip those types also upside down to get another one. We could pour them also at different heights. You could have higher heights or lower heights as needed within the overall height restrictions. Again, seen as a prototype, it was built for a specific site in Hamburg, but we could also build it somewhere else. Particularly, it works quite well in these northern sort of environments, and with basically 3 components: the wall pieces, the slabs, and then a window component. So also with the idea of being able to produce this quite quickly. So this is building this at a 1 to 20 model scale with our students in our studios out of a laser or a wire cut foam to show the system. But we could also see how stable, it was extremely kind of stable structural idea, but could spatialize quite interestingly on the interior, as well as kind of rippling, almost curtain-like exterior would produce these little, I guess they call them sort of cocktail balconies through here, but also really thinking about the project as a kind of residential one. So we also scaled the building accordingly for people to use as a low income, low cost, live work space. With Wholesome, after we won the European prize, they gave us enough money. We took the money and with Schleich's Research Institute in Stuttgart built a one-to-one mock-up prototype of the system here to see how it would work, to see what its appearance was, how we could sandblast later the surface of the building, and how these things could combine. So this then in turn allowed us to win a global prize with Wholesome to the next level, which, and again, sort of finances the next level of research.
Right, if you could wrap up now, where you're a bit over.
I'm right there.
Okay.
Yeah.
Thank you.
This is the last thing to show, but okay. This is a installation we did in Marrakesh for the Biennale last year, which is seen as a kind of prototype for a roof system, hyperbolic system. And I think the interest here was this we did with our AA students in the office, that we looked at a system, the software that produced a hyperbolic surface, but then looked at how that could be translated through local craftsmen and materials. So this is the project being constructed on site with local craftsmen, local wood elements, and Jan's system. This is Hamad, one of our workers who led the crew that produced this particular structure here. Again, as a kind of installation there, but anticipating this could be an industrial project for us. It could be rescaled. We could build this in the north in wood and steel, cable, as a kind of test of this idea, how it would spatialize and how it would fit in the context of this particular installation and its effects in light and in this place. So I think this idea of a kind of digital investigation, how that could be interpreted on the ground through local materials and craftsmanship. My last slide. On anticipating, I think, as I said, this is an evolving project. This is something we keep adding to and will continue to add to, but simply as a way to show how we work. Thanks, I'll finish with that.